So, good morning, all of you. How are you? Hope you all are fine, fit and fine. So, today we will discuss about JEE Main and Advanced Physics, and we will start the your unit number 3, like Newton's law of motion. So, we will start some question. So you can see on the screen, I share the screen. You can see the screen. There is unit number 3 from grade 11. So unit number 3, grade 11. This is your Newton's law of motion. First of all, you know about the Newton's law of motions. There are three law. You know what are the three law? If when the object is at rest or in motion, unless if we apply an external force, the object change its position, change its state. That is called Newton uh, first law. And Newton's second law, the force is directly proportional to rate of change of momentum with respect to time. And the third law, so in third law, the every action and reaction, action and reaction. So you know about, first of all, what is the Newton first law, second law, third law, and the formula regarding your Newton's law, and another more formula. Here is the first question: a particle of mass m is acted upon by a force F is a given by a spherical empirical law, y f is equal to r upon r square bt. If this law is tested experimentally by observing the motion uh, starting from the rest, and the best way to plot log bt against t. Second is bt against t square, log bt against 1 upon t square, log bt uh, against 1 upon t. So, you know, the what is the right answer from this question. So, how to find which is the right solution means you can calculate. How to calculate this can be calculated by, wait 1 minute, this can be calculated by, so this is your screen. I think, hope you can see. So first of all, you write F. You cannot see, I think. F is equal to R upon T square, T square into B. BT given. So first of all, according to Newton's second law, F is equal to M into A. M into A is equal to R upon t square into v. So you know what is acceleration? The rate of change of velocity is called acceleration. So dv by dt is equal to r upon t square into v. So dv upon v, rate of change of velocity, divide by velocity, is equal to r upon m. R upon m. So r upon m multiply by dt upon t square upon t square. So on integrating this, now we can integrate, you know the formula, 1 upon x is equal to log x. So now we can integrate this. So we get the value natural log of b, yeah, log b is equal to minus r upon mt. Think about it. R, wait, r upon mt, and here is dt. So you know how to integrate 1 upon t square. T square means t raised to power minus 2. Now if we apply the formula x raised to power 1, so minus 2 plus 1 upon minus 2 plus 1, minus 2 plus 1, apply the formula. So we will get the value, mean we can integrate this. So after integration, we use constant term c. So from this equation, which is the right answer? Here, the log bt against t first. Second is bt against t square. Third, log bt against 1 upon t square. But here is only t. So you can say that the log bt is against 1 upon t. Mean d is the right answer. So you think about how to calculate the value of this question. Now move on the second. We will solve all these questions. So second, the two forces P, Q of magnitude 2F and 3F respectively and are at the angle theta each other. If force Q is doubled, then the resultant also get doubled. Then angle theta is, mean you can calculate the angle theta. So angle theta, how can calculate this angle theta? So angle theta is calculated, means we use here magnitude triangular law of vector addition. So you know the formula. The formula is R is equal to, what is the formula? The formula is under root, you know the formula, P square plus Q square plus Q square plus 2pq cos theta. This is the magnitude. This is the formula to calculate the magnitude. So this is the formula. So according to question, we will write here the resultant R is equal to, yeah, you can directly here write here R square is equal to, first value is given f square. Yeah. Sorry, 2f square. So 2f square, 2f square plus 3f square, it's the whole square, 3f square plus 2, 2 into 2f into 3f, 3f into cos. Here is written as force angle theta is given. So we write here cos theta. So after that, if we solve this, r square. Here you can see if the force Q is doubled and then a resultant is also doubled. See here, Q is double and resultant is also double. So here we write here 2r square, because the resultant is double, then we can write here it's the whole square, 2r square. So simply we write here 2r square, that is equal to 2f square, 2f square plus, here you can calculate the value. uh, think its Q is double, mean this value, this is also double, mean 3, here is 6, 6f square, 6f square plus, next term is same, only just little bit change. Here is 2f, and in place of 3f, we write here 6f, because Q is doubled. That's why we write here 6f cos theta, cos theta. So after that, if we write this, so the value, if you solve the value from equation, this is your equation number 1 and this is your equation number 2. So if we calculate on solving this, now theta is equal to, 120 degree. You can solve easily. These are the two equation. So theta is equal to 120 degree. Here 2r square, 2f square, 6f square. Here is 12 into 24, 24 cos theta. Here is 3 into 2, 6, 6 into 2, 12. And all the value are same. So you can solve the, now the theta is equal to here 2f square. Mean theta is equal to 120 degree. A is the right answer. Now after that, so question number 3rd. Listen. A particle of mass m is moving on a straight line with a momentum p starting at a point t is equal to 0. Force F is equal to kt. Act on the same direction on moving a particle during the time interval t of the momentum change from p to 3p. Momentum is changed third time, the 3 time. So k is the constant. What is the value of t? You can calculate t. So how to calculate T? You can apply force on a spring F is equal to KT. F is equal to KT. Restoring of spring. So according to Newton's second law, F is equal to dP upon dt, the rate of change of momentum. dp upon dt is equal to kt. Simply we write here kt. After that, dp, the rate of change of momentum, dp is equal to, we write here kt, small t you write here, into dt. Now, after that, we can integrate this equation. Here, dp, so you can see the value. First value is p, and the momentum is increased by 3 times, mean 3p. And right side, you can write k remain constant, that is equal to k remain constant, initial time 0, final time t, capital T, and here is dt, dt, sorry, t into dt. If you solve this equation, now dp is equal to p. Simply we write here p. So 3p minus p. Simply we solve this equation. 3p minus p is equal to k t minus 0. So simply we write here t. So 3p minus p is equal to kt. This is your equation. So here, sorry, this is t into dt. So we write here t 1 plus 1, 1 plus 1 mean 2, divide by 2, apply the formula. So this is your right side, and t square minus 0 mean capital T upon 2. So 3p minus 2p is equal to, that is equal to 2p. 2p is equal to, and right side is equal to k capital T square divide by 2, divide by 2. So after that, we will find t square. So t square is equal to 2. Yeah, only you can neglect t square, 2 under root p upon k. P upon k. So you can see how to solve this equation. Mean your option number B is the right answer. So think about the question, you read the question carefully, and then you will find the right solution. So after that, uh, wait, after that, you can take the screenshot of this all these question. Now we will share the plain blank sheet. On the blank sheet we will solve the question. So you read or take the screenshot of question number 4. A ball is thrown upward with an initial velocity v0 from the surface of earth, then motion of the ball is affected by a drag force equal to mrv square, centripetal force, where m is the mass of ball, v is the instantaneous velocity, and gamma, sorry, here is gamma. Gamma is constant. Time taken by the ball to rise to its zenith is. So these are the 4 options. Which is the right answer? So I will share the white screen because you cannot identify how we write here. So you can see here the force acting downward is mg. First of all, the force acting downward, that is equal to mg. This is your question number 4. First of all, take the screenshot. So mg and mr, mr v square, centimeter force. So here Newton's second law, ma is equal to minus mg. So mg and minus the value is given minus m gamma v square, this is given. So this ma is called mean dv by dt. Displacement velocity upon time is called acceleration. So here m is given, so m remain common, so we can cancel out the mass. So here minus g and minus gamma v square. M remain constant, so we can cancel the value. Only just we solve a. A is equal to dB by dt. So after that 1 upon gamma remain common, and here we can integrate, the value is given v0 to v, and here dv upon uh, under root g upon gamma whole square. So the under root remain cancel out from the whole square plus v square So you will get here is equal to minus 0 to t, capital T, and here dt. Think about it how to solve this equation. So after that, uh, here 1 upon under root gamma into g, So here if gamma into g is given in the square root, so after integration you will find here tan inverse tan inverse b upon under root g by r. So the value is shifted on the right side, v0 to 0. So the integration of dt is equal to minus t, and here 0 to t. So calculate the value of t is equal to. First of all, you understand the question. What is the meaning of question and what he asked from the question? Gamma into g, and here tan inverse under root gamma upon g into b0, upper limit minus lower limit. So I think this is the right answer. So we can see on the screen which is the right answer. So wait, T is equal to R upon G. Wait 1 minute. T. Yes, this one. So we will find T is equal to 1 upon under root RG and tan inverse RG, tan inverse. Here is log, here 10, here 10. This is not a option because 2RG. Here tan inverse gamma upon G into B0. It means your option number B is the right answer. B is the right answer. So you can understand how to find this value. So this is some complicated question. Now move on to question number 5. So question number 5 is a bullet of mass 20 gram has initial speed 1 meter per second just before it start penetrating a mud ball of thickness 20 centimeter. If the ball offer a mean resistance of 2.5 into 10 raised to power negative 2 Newton, the speed of the bullet after emerging from the other side of the wall is close to. So think about it, you will find the velocity. So how to find the velocity? First of all, you remember what is the question? The bullet of mass 20 gram, initial speed 1 meter per second, just before it start penetrating the mud ball, and thickness is 20 centimeter, and it the ball is of a mean resistance 2.5 into 10 raised to power minus 2 Newton. And the if the bullet uh, emerging from the other side, then close to us. How to close to us? You will find the velocity. Mean question number 5. So question number 5. How to solve question number 5? So this is you take the screenshot of question number 4. So after that, uh, question number 5. So how to solve this question number 5? Initial velocity, listen. Initial velocity is equal to 1 meter per second. Initial velocity is given 1 meter per second. So uh, F is equal to ma, Newton second law. So A is equal to, because it is recoil of gun, minus F upon M, F upon M. So the resistance force is given minus 2.5 into 10 raised to power minus 2. I think I read minus 5. So the mass is given 20 centimeter, convert in meter, 0.02, 0.02, and S is given, displacement of the bullet is given 0.2 meter, 0.2 meter. So after that, we use the kinematical third relation, velocity displacement relation. V square minus U square is equal to 2AS. Now use this equation. So V square, now you know the initial velocity is 1. 1 square is equal to 2, and acceleration, uh, you can see in the upper side minus 2.5 into 10 raised to power minus 2 divided by 0.02, 0.02 and multiply by 0.2 displacement. It penetrate, so we write here 0.2. After that, if you solve v square, so you know 1 square is equal to 1, so that is equal to 1 minus. So if you solve this equation, 2 remain cancel out. So here minus 2, 1, 0 remain cancel out. So I think this is 0 0.5. 0 0.5. This is very easy. So you can see 0 0.5. So if 0 0.5, so v square, here v, you will find, so v is equal to, I think 0 0.7, 0 0.7 meter per second. So again we share the screen, which is the right answer. So you can see first A. First A is the right answer. Mean it penetrate about the space behind 0 0.7 meter per second. So question number 6. This is very easy question. If three forces F1, F2, F3 are represented by the three sides of the triangle, F1, F2 is equal to minus F3. So then there are three, this is called concurrent forces, and three forces are concurrent forces are satisfy the condition of the equilibrium. This is the statement one. Statement two, a triangle made by the three side F1, F2, F3 are the side taken in a same order satisfy the condition for translatory equilibrium if the light of the above statement. Choose the most appropriate answer from the option given below. Means your statement 1, statements 2, statement 3, which is the right answer. Yeah, statement 1 is true, statement 2 is true. So first of all, you read the question carefully. Listen, statement 1, if three forces F1, F2, F3 mean, I think your statement 1 is correct because this is concurrent forces. F1, F2 is equal to minus F3. These three forces are concurrent forces, so satisfy the condition for equilibrium. I think statement 1 is satisfied. Mean true. Now, a triangle made F1, F2, F3 are its side. So same order satisfy the condition of translatory equilibrium. Then the light of the above statement choose the appropriate. So how to find this equation? This is very easy. So you can see this is your F1. F1. Only the statement first is the right here. This is your F2, and in this direction there is your F3. So you write the condition same as it is. I think F1 plus F2 plus F2 is equal to minus F3 means statement 1 and statement 2 both are true. Statement 1 and statement 2 both are true. So this is the right answer of your question number 6. So after we solve the question number 6, we share one more screen, means your question number, wait, here one question is left in the previous one. This is on the screen. Wait. Yes. This is your question number 7. Listen carefully. A force F is equal to 40I plus 10J Newton act on a body of mass 5 kilogram. If the body start from rest, then its position vector R at time t is equal to 10 second will be. So read first of all question number 7. A force F 40I 10J Newton act on the body of mass 5 kilogram. If the body start from rest, the position vector R at the time t is equal to 10 second. Means you will find the time period after the 10 second. So after the 10 second, sorry, after 10 second, you will give the answer A, B, C, and D. So first of all, how to solve this question? So this question is again, we share the plain uh, sheet. So on the plain sheet, we will share the question. So think first of all, we will use the relation according to position vector R, mean velocity displacement relation. R is equal to ut, mean S is equal to ut plus half a t square. But here position vector is given. So 1 by 2 a t square. So according to position vector, we use here R. So here that is equal to 1 by 2 1 by 2 initial velocity is 0. This is 0. So right from the here 1 by 2 and A force F is equal to MA. So we will find A is equal to F upon M. F upon M and multiply by T square. Multiply by T square. So you think what is the value of F? F is given 40I plus I think 10J Newton. 10J Newton and divide by 2 and mass is given 5 kilogram. 5. So time is given 10 after 10 second, mean 10 multiply by 10. So here 5. So this 5 is again cancel out. So 40I plus 10J. So multiply with 10. 40 multiply by 10 mean 400 I unit vector plus 100J. Very easy question. 100J. So this is your answer. So you can check on the screen which is the right answer. So I think 400I plus C. C option is the right answer. You can see C 400I plus 100 J meter. So displacement. So move on the question number 8. So question number 8 is a body of mass 2 kilogram move under a force 2I plus 3J plus 5K Newton. F is given. Mass is given. It start from rest and was at the origin initially. After 4 seconds, it's a new coordinate r 8 b 20. The value of b is round off is the nearest integer. You will find nearest integer. So I think there is no option is given for this question. So you will find the nearest. So how to find? So again we share the plain screen. So you will find the right answer. So here in this question, Fy along y direction, that is equal to 3. That is equal to 3. So force is equal to F is equal to ME. So AY is equal to Fy upon M. Fy divided by M. So Fy divided by M mean 3 by 2. So it means the acceleration is 1.5 meter per second square. We can calculate the acceleration. So acceleration is 1.5 meter per second square. It's along y. So for the y direction, we use again y is equal to ut plus half at square. Half at square. So y in the question is told me the told us the initial velocity is 0. So here is 0, initial velocity is 0, so this is 0. So 1 by 2 multiply by acceleration is find 1.5 and after time 4 second mean 4 square. So if you solve 16, 8 multiply by 1.5, 1.5. I think the displacement along the y-axis is 12 meter. Integer will in the question integer is 12 meter. So one more last question we will find. So last question is means this is the ninth question. A force on the object of mass 100 gram is 10I plus 5J Newton. I think you will solve this question. So we will solve the question number 10. You will try this question number 9. You can take the screenshot. Now think about this question number 10. So we will complete all the 11th question. An object is thrown vertically upward at the maximum height, which is the falling quantity become 0. One object is thrown vertically upward at the maximum height, which of the following quantity become 0. So you know the momentum is equal to mass into velocity. Object is thrown upward. If the object is thrown upward at the highest point, the velocity of the stone is 0. B is equal to 0. So if B is equal to 0, it means the momentum is also equal to 0. If V is equal to 0, then momentum is also equal to 0. P is also equal to 0. So your answer is momentum. Here written, object is thrown vertically upward at the maximum height. Which of the following quantity become 0? Here mass is not given. Mass is a constant quantity. So momentum remain 0. So you can say A option. Now move on the last question. Last question is a block of metal having 2 kilogram is resting on a frictionless plane. Wait 1 minute. Yes, frictionless plane shown in a figure. It is struck by a jet releasing water at the rate 1 kilogram per second at a speed of 10 meter per second. Then the initial acceleration of the block in a meter per second square, it will be here 2 kilogram. Now we will find the acceleration. So this is very easy question. So you can see, first of all, again we share the plain sheet. So read the question properly. So first of all, F is equal to ma, Newton second, ma, and A is equal to 1 upon m, 1 upon m, and here we write delta P, delta P divided by T. You think how to change the formula? So here that is equal to 1 by m, 1 by m, and delta momentum is equal to mass into velocity divided by time t, time t. So A is equal to 1 by 2, mass to 1 by 2 multiply by 1 multiply by 10. So it is acceleration is 5 meter per second square. So these are very easy question. So in next class, we will solve another more question like pulley, inclined plane, banking of cyclist. So first of all, you need to learn the formula and which formula is applied in which question. First of all, you know how to find the question, which formula is implement in which question. So think about it. First of all, you read the all the formula and then we will solve the question. So thank you. Meet next time. Okay. So